Hello, and welcome to the VMC Quick Course Series. My name is Wayne Wilson, and I'm a software consultant for the MainView family of products. In this demo, I'll show you how to use MainView for ZOS to view and manage devices. As we have done in other quick course demos, start at the EasyM ZOS menu, then hyperlink on Devices. This takes us to the EasyM Devs view, or the Devices Activity menu. You can see that MainView for ZOS provides a number of options for viewing device-related data, including cache, channel and control unit metrics. There are also options for viewing devices at the SMS storage group level, only tape devices, and there is also a link to the MVScope utility to perform I/O traces. To get started, hyperlink on device utilization to get more information about how devices are performing. The DevStat-Z view provides summary information about all monitored DASD devices. This view is useful to understand the amount of I/O activity that is being driven against the DASD, as well as average response time of that I/O activity. The view even breaks down the response time metrics into component IOSQ, connect, disconnect, and pen times. And by hyperlinking on the various columns, you can navigate to different analytical options as follows. Note that there are now some more volume-specific options available, such as datasets allocated and open, as well as links to determine what jobs are using the volume and which jobs are being delayed by I/O response. Similar to other views in MainView, you can obtain a historical view of DASD performance by using the time command. Use the time command as you see here to show the last 4 hours of DASD performance. This is a historical view of the data over 4 hours. However, because we are looking at DevStat-Z, which is the summarized version of the DevStat view, each volume is shown on a single line, with the intervals averaged together. To see all of the intervals, place the cursor on a vol-seer field and press Enter. This is the DevStat view. It is the unsummarized form of DevStat-Z. Using DevStat, you can see the history of I/O rates and response times. Now press P(F)(3) to return to DevStat-Z. So far, we have seen how to look at DASD volumes in the current interval and over time. However, DASD devices are typically shared by 2 or more LPARs. To get a more accurate picture of DASD performance, it's a good idea to use the MainView Context All command to see all activity for the MainView CASPlex. Now we are looking at the DevStat-Z view with a context of all. As a result, we are seeing a summary by device name of all instances of the devices on all LPARs. But there is a nuance that you should be aware of. As you can see in the header of the online help, the metrics are averaged for both I/O rate and I/O response. This is good for the response metrics across LPAR, but it is probably better to see the I/O rate field as a total I/O as opposed to average. So here is a recommendation. Customize this view as follows. In View Customization, change the summarization type from A, meaning average, to S, meaning sum. This will cause the DevStat-Z view to total the I/O of each contributing LPAR for a much more accurate display. Now the view shows that the I/O rate is summed, and now we have better numbers. Now let's return to the Device Activity menu by pressing F3 until we get back to EasyM Devs. Hyperlink on Cache Overview, and let's examine the effectiveness of DASD caching. The Cache Stas view shows information about cache activity at the controller level. Each I/O controller in the DASD farm contains some onboard memory in which data that has been recently read from physical DASD is temporarily stored. The idea is that a subsequent read of the data can be satisfied from cache memory, thus eliminating the physical read and improving I/O response. Similarly, write activity often can be completed to cache, and the physical write performed at a later time when the device is less busy. This also improves I/O response time for the application. When looking at cache stas, the important metrics are the read hit percent and the write hit percent. This is an indicator of how effectively I/O response is improved by caching. The first two columns indicate the storage director ID of the cache controller and the number of DASD volumes that are serviced by it. If you wish to see how well each device is doing, hyperlink on the SDID field to navigate to the cache stat view. The cache stat view shows the detail of all devices serviced by the cache. You can hyperlink on the device number to examine detail metrics about the device, or else hyperlink on the VolSeer to identify which datasets are currently driving I/O against the device. But let's press PF3 twice and return to the Easy MDevs menu. The next few menu selections are just access paths to views that we have already seen, so let's skip down to SMS Overview and see what it has to show. The SMS stat view is intended both as a summarized display of I/O activity at the SMS storage group level and as a link to see the actual VolSeers that make up the storage group. Note the TOTEDEV and ACTDEV columns. TOTEDEV shows the total number of devices in the storage group, and ACTDEV shows how many devices have actually had any activity during the current recording interval. Hyperlinking on group name, or SGNUM, will take you to the SMS info view, which is a summarized form of devinfo. Hyperlinking on any other field will take you to a filtered devstat view, which we have examined before. Now press F3 until you return to the Easy MDevs view again. For a final exploration, let's hyperlink on tape devices. This is the tstat view. It is actually just a slightly customized version of devstat, but with a couple of important differences. Obviously, it is filtered on 3490 and 3590 device types, but it also includes several tape mount fields to show if mounts are impacting performance. The MTP time field will show how long a current mount request has been outstanding, and if you scroll to the right, you will see the total number of mounts for the job as well as the total amount of time that the job has waited for mounts to complete. tstat is an excellent view for showing a context of all. This is because tape drives cannot be simultaneously shared between LPARs the way that DASD devices can. So using context all will show you which LPARs are currently using which tape drives. tstat is also an excellent view from which to drive alarms from MainView Alarm Manager. Just create the alarm using the MTP time field when the elapsed time for a tape mount exceeds your operations response time objectives. Well, that should give you a good overview of using MainView for z/OS to view and manage devices. As you have seen, you can view individual DASD and tape devices, logical and physical channels, storage directors, and cache storage. You have options to summarize the data or to break it down by device type or SMS storage group. And you can use the features of the MainView architecture to analyze devices in both real time and in history. For more information about MainView for z/OS, see the related demos box. For more information about any BMC mainframe product, please visit the URL shown here. And thank you for your time.